Hello guys, welcome back to our channel Career at Market Value. I am Analyst 1. So the topic of today's discussion is estimating value at risk through PARCH, assuming a normal distribution. So guys, one important thing I wanted to let you know that the equation that we are estimating, if you guys have gone through my previous videos, you must be knowing that we are estimating the equations on the full set of data. I mean starting from here till down, that is 100% of our data. But a refined approach would be to estimate our equation on 70% of the data, which is still here till 3277th point, right? So I think going forward our modified approach would be to estimate equation on 70% of the data. So let's check where our 70% of the data starts. So the 70% data ends over here, which is 11th of November 2010, right? Let's group this, go up, and let's delete this part as well. I will tell you why this standard deviation has a power over here. So I'll let you know guys why is it so. Let's group this once again. Okay, now let's go to eViews. So this is our eViews. So let's open our file, foreign data as work file, the path, there you go, next again, then finish. So yeah, so we get our data. Now we'll estimate the equation. Go to quick estimate equation, right over here, returns space C, this is our equation. Now the range guys will give us what we have got as our 70% data point. So let's make the same over here, 11th of November 2010, 11th of November 2010. So this is the 70% of data. We'll estimate our equation on the 70% only. Let's click on arch and make this as PARCH. Let's keep this as 1 and 1 and error distribution as normal. We are assuming normal distribution, right? So click on OK. See, it's iterating over here, and this is the equation that is finally generated. Okay, so let's copy the coefficient at first somewhere here. So there is C2 till C6. So C2, C3, C4, C5 and C6, right? So C2 is this, make this as number, C3 is this, paste it, C4, C5 and C6. right? Now let's compute the long run variance similarly as we did for other equations. So this is for the standard deviation part, so we'll paste it over here. Let me copy the format. Now the standard deviation is simply square root of this. VAR will be this multiplied by norms inverse, since it's a normal distribution, that's why probability would be 5% for 95%, then 2.5% for 97.5%. These are the significance levels, guys. Then for 99%, 1% would be the significance level, and finally 99.5%, 0.5% would be the significance level. Now let's copy our equation, which is this. Looks hideous, isn't it? So let's copy this, okay, paste it over here. Now, so now we got our equation. So our equation implemented data will start from here, guys, this cell, right? So it says square root of PARCH, which is standard deviation, to the power of C6, and C6 is basically this. So we'll simply copy this and go up and change this value which was earlier been pasted. So this is our cell. It says standard deviation to the power of this C6. Okay. Now standard deviation to the power of 6 is simply equal to C2, which is this coefficient. I'll copy this, okay. Then it says C3, which is this, plus C3 multiplied by absolute ABS, then residual n minus 1. So residual n minus 1 should be this, right? Residual n minus 1, close brackets, okay, close the bracket, then again for ABS and again for the conjugate. So there you go, minus of C4, right? So let's copy C4 for that part, okay. So minus of C4, which is already a negative value, multiplied by, let's give an open brackets, then multiplied by residual n minus 1. So for this part, guys, I suppose we should put an extra negative sign, since this value is already negative, and let's do some more modification. Apply absolute. Why I am doing this, I'll let you know. So absolute, then our residual n minus 1 as it says, right? And then to the power of C6, which is over here, that is 1.17681, right? So why I did this, guys? Because if I haven't put an absolute outside and directly did this powered formula on my residual n minus 1, this would have given me a num value error. If I don't do absolute, I don't write absolute over here and simply raise this term d3278 to the power of this value, then this will give me error. Excel will give me error since this is a negative value. So I have put in an absolute in front of this, and since it was a negative value, so I again put the minus sign in front of it, right? So now I will close the brackets there and go to my standard deviation, which is this, and it says to the power of C6, which is 1.176841, right? So I close the brackets, again one more bracket for this conjugate to close, and press enter. Okay. Now we should express this as percentage. Yeah, now we have converted this into percentage. There is something written over here, let's delete it. So the value we got here, guys, is simply standard deviation raised to the power of 1.176841, which is this, right? Which is this. Now for our variance estimation, which should be standard deviation to the power of 2, or it should be square of standard deviation, right? So how will you convert standard deviation to the power of 1.176841 to standard deviation to the power of 2? It will simply be this conjugate raised to the power of 2 divided by 1.176841, right? So there you get your variance. Let's convert this into variance. Yeah, now the rest of the things, standard deviation and value at risk estimation through probability of confidence interval from 95% till 99.5% would remain the same. So we can go ahead and simply copy this down below and drag all of this conjugate to the bottom. Okay, so daily VAR estimation is complete, and we delete every other thing that is over here. Let's delete this, let's delete the equation and delete the coefficients as well. So now it's done, guys. So the estimation of value at risk through PARCH assuming a normal distribution now is complete. So in the next video, guys, I will estimate an equation for PARCH assuming a student's t distribution. So that's all, guys, from today's video. Stay tuned for our next video, and do share, like and subscribe to our channel if you like this video, and do comment down below. Thanks, guys.